Well, hello guys. Seem to have an issue. So, I kind of have a soccer ball stuck up here. And I would really like to get it down. However, I'm not super comfortable with ladders. And I was reading on these directions here, and it says that the safest angle with the ground that the ladder can make with the ground, so this angle down here, the safest angle is 75 degrees. Okay, so I really want to make sure that I am not gonna fall. So I think probably if I get this within 5 degrees, like from 70 to 80 degrees, I think we're probably safe. Okay, so we have, I can even see it with the shadow here. I've got a right triangle. Okay, so my right angle is down there. There's my angle that needs to be 75 degrees. Look at that lovely triangle. It's beautiful. It's beautiful, it really is. Okay, so I just need to know if that angle is around 75 degrees. Okay, and I measured the distance from the ladder to the house on the ground is 3 feet, and the ladder is 10 feet. Is there any way that we could use Trig to figure out that angle? Just, it would really help me out so that I can get that ball. I don't know. I just think you could help me out. And we need to find an angle. There must be some way to like undo Trig. Like if you know the two sides that make the ratio, one of the Trig ratios, then you should be able to find the angle, you would think. Yeah. Anyway, I really want to get my kids their soccer ball down, but I just really don't want to fall. I have to teach you guys later today, and yeah, I don't want to fall before then. So anyway, if you could help me out, that would be fantastic. Thanks, guys. Okay, so I think I made a good representation of this on this board down here. All right, so here is the house, and this ladder is 3 feet from the house. The ladder's 10 feet, and we want to find that angle. Okay? And I was saying that I really think that if there is a way to calculate the angle, if we know the trig function, like if we look at here, if we look at this angle, from this angle we've got the adjacent and the hypotenuse. So we know that the cosine of angle x has to equal adjacent over hypotenuse. So it has to equal 3/10 or 0.3. Okay, so I don't know. I mean, I could try things out. Like I could say like the cosine of, let's just guess 60. So maybe it could be 60. The cosine of 60. Okay, that's 0.5. Okay, but we need 0.3. So does that mean we need to go down? Oh, the cosine of, say, 50. Cosine of 50 is 0.64. Wait a minute. That went up. So does that mean... Okay, so let's just try, like, the cosine of 65. It's 0.42. Okay, so I guess the bigger the angle, the smaller cosine. So am I just going to have to keep guessing? There's got to be an easier way. Got to be an easier way. Well, let's see. How about this second button up here? That's like a shift button. So what if maybe it's like the opposite? Okay, so let's try. Okay, so that's second cosine. That gives me like the inverse cosine. So if I enter the cosine think maybe it'll give me the angle. So it's 3/10 or 0.3. I'm just going to go 3 divided by 10 because I think that's really easy. Okay, and so then I get 72.54. Hey, I bet that's the angle. That's this angle, I bet. Okay, so that means the measure of angle X is approximately 72.5 degrees. Now, is that in my safe zone? I said 75, it says 75 degrees is like the recommended angle. And I figure if I'm within 5 degrees or so, I should definitely be safe. Okay, and I am. All right, so that means that I can go up here and grab my soccer ball. And I should have no trouble, assuming I don't trip. I probably should change out of sandals. All right, well, thanks for your help, guys. So I'm feeling pretty good now that we calculated that this ladder has been put up safely. I've also taken another safety step. I changed from my sandals to my shoes. Okay, so should be safe there. So I'm feeling pretty confident. Okay, let's see if I can do this. All right, got this. Almost there. I think you got this. Yeah! Got it. All right, so this inverse trig thing that I was talking about, it's a real thing, and we use it to find angles. We use regular trig, which is the kind of trig that you did in the last section. We use regular trig, just the regular trig buttons, no shift or second button to find side lengths, but to find angles, we use inverse trig, or we use that second button or shift button. Okay, so if we're going to find this angle A, that's what I'm trying to find, the measure of angle A, I am going to look at what two pieces I have. And it appears that I have opposite and I have the hypotenuse. Okay, so from angle A, I've got opposite and hypotenuse. Which trig function uses opposite and hypotenuse? Okay, so opposite and hypotenuse would be sine, you're right. Okay, sine of angle A is equal to opposite over hypotenuse. So opposite, 8 over 11. Okay, and that's true. The sine of A is equal to 8 over 11. But what we need to type into our calculator, it's going to look like the inverse sine 8 divided by 11. Okay, and that will give us our angle. I'm going to type that into the calculator. Second sine, so then it gives you a little -1, so that's the inverse sine, and then 8 divided by 11. All right, so there it is, and it looks like the angle is 46.658, yada yada yada. Okay, I'm just going to round that to the nearest tenth of a degree, so I'm going to say 46.7 degrees. Okay, a lot of times they'll even say round to the nearest degree. Okay, but it's approximately equal, make sure you have the squiggly equals, to 46.7 degrees. All right, okay, so now I'm going to give you guys a couple to do. Okay, right here. All right, and I'd like you to pause the video and see if you can figure out these two problems. Go for it. All right, let's see how you did here. Okay, for the measure of angle D, two parts we've got are opposite and adjacent. So you said it, it's tangent. So you're just gonna type into your calculator, second tangent, 6 divided by 4, and you get approximately 56.3 degrees. How'd you do? I can hear the confidence in your voice, which is strange because this is not live, but I can tell you're confident. Now let's look at this one. Okay, from the G we've got adjacent and hypotenuse, which would be which trig function? Yes, you said it, cosine. So the cosine of angle G is equal to 7/9. So you're just going to type in second cosine 7 divided by 9 and you get approximately 38.9 degrees. Fantastic, guys. Good job. All right, so the last little piece of trig that I'd like to discuss with you, it's called angles of elevation and depression. Okay, and I just saw a beautiful bird up in this tree. Okay, but he flew away, so I had to recreate the situation. But, okay, if you look at my lovely drawing here, and you all know my artistic abilities, my 3-year-old just asked me if I was trying to draw ice cream. So, anyway, this is me looking up at this bird. Okay, and there are 2 angles that I want to discuss here. Okay, one is called an angle of elevation and one is called angle of depression. Okay, if you look at me here, okay, if I'm just looking straight out, parallel with the ground, this is my line of vision or my line of sight. Okay, the angle from whatever I'm looking at to that line of vision, that's called either an angle of elevation or an angle of depression. And if you look here, I'm looking up at the bird. So if I'm looking up, then that's called an angle of elevation. Okay, so this right here is an angle of elevation. Okay, then if I look over at this bird's line of vision is this dotted line. Okay, this dotted line is the bird's line of sight or line of vision if he were looking straight out, but he's looking down at me. Okay, so if I'm looking at this angle, the angle where he's looking down, that's called an angle of depression. Okay, and it doesn't mean he's sad, but if you remember kind of that he's looking down, that's an angle of depression. Okay, and we're going to use this in a story problem. Sounds fun.
Bye.
All right, so here's Sven, and Sven somehow has made it to the top of the snowman. Sven really wants to ride that zip line. Okay, and somehow Sven has to miraculously get to the beginning, the top here. He needs to get up there so that he can ride it. Okay, and he wants to find the shortest distance from where he is to that spot. So, if you look at Sven, okay, Sven's line of vision is right here looking out. Okay, and he's at an angle of elevation up to the start of the zip line of 65 degrees. All right?
65.
Yep. And the height of the snowman is 3 feet 6 inches. The height to the spot that he's going on the tree is 9 feet 6 inches. We want to know this diagonal distance from where Sven was until he fell off the hat to that spot right up there. So let's try to calculate that. All right, so I realized too late that I did not explain that well. So Sven is no longer on the top of the snowman. So I thought I would explain this maybe a little bit better. Okay, this is not drawn to scale. Okay, but you will see Sven, I really did try, on top of the snowman. Okay, and then here is the start of this zip line right here. Okay, the snowman's height is 3 feet 6 inches, And the height from the base of the tree to the start of the zip line is 9 feet 6 inches. Okay, and the angle of elevation, okay, or the angle from Sven's line of vision looking up at the zip line is 65 degrees. All right, so we have to figure out the distance here. We're looking, I'll put an X. We're finding that distance, okay? And so we have a couple of things. We have this angle of elevation, and we actually do have one side of the triangle. And this is where it gets a little tricky. Okay, we know that this is 3 feet 6 inches. We know this is 9 feet 6 inches. Okay, so what would this piece right here be? This is 3 feet 6 inches. Again, I said it's not drawn to scale. This is 9 feet 6 inches. So what would this piece right here be? Yes, it would be 6 feet. Okay, it's 9 feet 6 inches minus 3 feet 6 inches. That makes this 6 feet. This is actually the triangle that we have, and we're trying to find this. Okay, and so now this looks like a nice little trig problem like what we've seen before. Okay, so from the 65 we have opposite and hypotenuse, and what trig function is that? Yes, sine. So the sine of 65 equals opposite over hypotenuse, so 6 over x. X is in the denominator. We're going to divide 6 divided by the sine of 65. Okay, so this is approximately this distance, the distance that Sven needs to fly, or however he's going to get up there, is approximately 6.62 feet. Okay, and I'll put that into inches. I'm going to take my 0.62 and put that into inches. So I'll multiply that by 12. I'll just round to the nearest inch. 6 feet 7 inches. That is the distance that Sven will have to fly, or whatever he does for transportation. All right, so there we go. I hope you have a wonderful day. It's beautiful outside. Go do something outside. No snow, just beauty. All right, have a great day.
Hi guys, welcome back.